in the first two examples we did, everything worked out nicely. I want to do an example where things don't work out as nicely because it won't be the optimal situation for trig functions either. So I'm going to look at example 1.1.4. I'm going to look at x squared, and I want to know what is the inverse of x squared. All right, you're screaming, it's the square root. Square root, don't be silly, we know it. Well, let's see. You're partly right and partly wrong. So if I sketch y equals x squared, what I'm getting, I have a point at 1, 1. I have a point at 2, 4. I have room for one more at 3, 9. And then all the negative values as well. And then minus 3, 9. All right, so something like this, not the best. Let me start over. Yeah, and keeps going. All right, so we learned that you have to flip it on across y equals x, or you could switch the order of x and y. So let me switch the order. I find that sometimes is easier to see if you've put a few points. So 2, 4 becomes 4, 2, 3, 9 becomes 9, 3, and then I have 1 minus 1, 4 minus 2, and 9 minus 3. And so here's the graph that I have. All right, so this would be the candidate for the inverse of x squared. The issue I have with this, and you'll see it in B, explain why the potential inverse is not a function. This is not a function. It's not a function because if I look at the value of that function at 9, for example, I would have two different options for it. So I would need f of 9 to be both 3 and f of 9 to be minus 3. But one thing that we know about functions is if you plug in a number, you get one number out, not two different ones, and so it's not a function. The same would be true for 4, for 1, and for all positive number. And so what we've done to define an inverse, to get a square root, is instead of looking at both branches, we just picked that we liked positive number before. We like positive numbers more, and so instead of looking at the two branches, I only look at the right branch. And so that's what we'll do here. Graph y equals x squared on the restricted domain x is greater or equal to 0 to find its inverse. All right, so let me do it quickly since we've done it before, but this is the part I want to look at, x bigger equal to 0, and if I flip it, this is what I get, which is square root of x. Notice that here, when I draw my vertical lines, it intersects at only one point, and if I draw the same lines here, but put them horizontal, because when you switch x and y, that's what happened, it flips from vertical to horizontal, these intersect only once. While here, I'll draw the same one, the equivalent one, the corresponding one to x equals 9. So this is y equals 9. This one intersected at 2 points. All right, so in the next video, we'll make this precise. We'll talk about the vertical line test and the horizontal line test. And then we'll be ready to start inverse trig functions.